Support handout number 20. Problem number 1, we want to find the smallest positive coterminal angle. Remember, that just means adding or subtracting multiples of 2 pi, or 360 if I'm in degrees, until I get what I want. So when I look at part A, 3 pi over 5, that's already a pretty small angle. All I have to do is add 2 pi to this and I'll have what I want. I will write 2 pi as 10 pi over 5 so that I have that common denominator. Looks like the answer then would be 13 pi over 5. Letter B, I have a negative angle in degrees. To get that positive coterminal angle, all I would have to do is add 360. And when I do that, I'm going to get 336 degrees. Letter C, again, a negative angle in radians. I think I might have to add 2 pi a few times here to get what I want. If I just added in 2 pi, that would be 8 pi over 4. That's still going to be a negative answer. Negative 19 plus 8 is still negative. So I think I'm going to have to do it a few times. Let's see, negative 11 plus 8 is still negative. One more ought to do it. In other words, I think I needed to add 6 pi into this thing, 2 pi 3 times. Negative 19 plus 8 is negative 11, plus 8 is negative 3, plus 8 is positive 5. And so I finally found a positive coterminal angle. Letter D, 1,000 degrees is large. So I can find a smaller positive coterminal angle. Now what I need to do is repeatedly subtract 360 degrees. If I do it once, I end up with 640 degrees. But I can do better than that. I can subtract 360 again and end up with something even smaller. When I do, I get 280 degrees, and that's as good as I can do. If I were to subtract 360 again, I would be in the negatives. Part E, 23 pi over 2, I think I'm in the same situation. This is a very large angle. I'm going to be able to subtract some 2 pi's until I get down to what I want. Now, if I just subtracted 2 pi once, I would write that 4 pi over 2. I can see that's only going to take me down to 19 pi over 2. That's still very large. I need to subtract some larger multiple of 2 pi. How about 20 pi over 2? 20 pi over 2 would be 10 pi. 10 pi is a multiple of 2 pi. What does that get me to? That's 3 pi over 2. Can I do it again? Can I subtract another 2 pi, another 4 pi over 2? I can't do it. That would take me down into the negatives. And so it turned out that subtracting 10 pi got me to the smallest positive coterminal angle. Letter F, if I were to subtract 360, it would take me into the negatives. So what I will have to do is add 360 degrees, and that takes me to 681.87 degrees. Problem number 2, we want to draw each of those answers now in standard position. So for part A, I have the angle 13 pi over 5. It would probably be easier to sketch 3 pi over 5. I know that these two angles are coterminal, and then I can just adjust my rotation arrow. I am trying to be accurate, so maybe I should switch to degrees. Let's see, if I mentally put in that 180 here for pi, 5 goes into 180 36 times, and 36 times 3 is 108. So I'm drawing basically 108 degrees. That's going to be right about here. Now, if I was doing 3 pi over 5, I would have a very small rotation arrow, but I know where that 13 pi over 5 came from. I went around one full revolution, the 2 pi, plus the original 3 pi over 5. And so here would be the final drawing for that angle. Letter B, I'm drawing 336 degrees. That is 24 degrees short of making it all the way around. So something like this. Letter C, 5 pi over 4, that's actually one of our nice angles. It's got a 45-degree reference angle. It's the one in the third quadrant. And so here is the answer to part C. Letter D, 280 degrees, that's a little bit more than 270. So I'll go a little bit past the 270, 280 must be somewhere right around here. E 3 pi over 2, we've drawn that many times. That is 270 degrees, so that's this angle. And then F, let's see, 681. Maybe I'll look at the original angle first. It was 321.87. That is a little less than 40 degrees short of a full revolution, so something like this here. But of course, I'm drawing 681.87, which means I have to rotate all the way around plus that original angle. Here would be the final drawing. And then problem number 3 is a review from algebra. I want the equation of the horizontal line that goes through this point. Well, what you have to remember from algebra is that all horizontal lines have the same looking equation. It's always y, an equal sign, and a number. Of course, the only y number in this problem is 6, so the equation must be y equals 6. The idea here, if I graphed that point, here's the point 3, 6. Well, 2, 6 must be on the line 1, 6. It's a horizontal line, so the y coordinate is always at 6. Similarly, vertical lines in algebra are always x equals a certain number. The certain number here is 5, and so the equation must be x equals 5. This would be the line that, yes, it goes through 5, negative 13 somewhere down here, but also 5, negative 5, and 5, positive 6, and 5, everything. It makes this vertical line, all the x coordinates are at 5.